So we have discussed about the first node here, the breadth first search. We have discussed about the breadth first search. Now another search technique under the uninformed search strategy is the DFS, depth first search. So what comes under this? We may sometimes search the goal along the largest depth of a tree and move up only when further traversal along the depth is not possible. We do this. We then attempt to find the alternative offsprings of a parents of a node last visited. If we visit the nodes of a tree using the above principle to search the goal, we are using the depth first traversal. So here we are talking about the height or the depth of a tree here. So how you will define a depth first search, or what definition you will say about the depth first search? Depth first search is a graph traversal technique here also. We traversal all adjacent vertices one by one. When we traverse an adjacent vertex, we completely finish the traversal of all the vertices reaching throughout the adjacent vertices. So how it is different from the BFS? BFS और BFS में difference क्या हो गया? BFS में we are talking about firstly we will uh, expand all the childs and then the further childs of a then in the depth first we are saying that पहले एक ही child को पूरा depth तक हम expand करेंगे. After that we will talk about the another child. So here, so depth first search is how you use the depth first search. Let's take an example here. G is a goal state. Let's see. A state space search initially fringes only the node for A. Yeah, this is a state space search. Now A is here. After that A, let's take the same graph that we have taken in the DFS. The root node is here A and the child nodes of a is B and C. So in a step 1, A is removed and A is expanded and its children B and C are put in a front fringe. So here the B and C will be there. And now node B is removed. Who are the child of our node A, which is the root node, is B and C. Firstly, the B will be removed from the fringe and its children D and E are pushed in the front of a fringe. What we were doing in our DFS, firstly we were expanding B and then we were expanding C. But in that case, we will expand first B completely and then we will expand C completely. So node B is removed from the fringe and its children D and E are pushed in the front of a fringe. So the frontier here is now the D and E. And in the node D is removed and C and F are pushed in the front of a fringe. C अभी वहीं पे ही है जो second child था A root का here, right? And we are expanding to the depth of a child B here. So firstly A will be removed, then the B will be removed, and then the D will be removed. And after removing the D, its child C and F will be pushed. And now what is the frontier here? C, F, E, and C. So first now here is the C and F. And now the C will be removed and its child G is pushed in the front of a fringe. Right? Now in that case, G, F, E, C is the another traversal node. Now G is expanded and found to be a goal node. अब यहाँ पर G goal node मिल गया है. So node G is expanded and found to be a goal node. In that case, the solution path we found here A, B, D, C, and G is returned and algorithm terminated. Right? So in this, the solution path A, B, D, C, G is returned and the algorithm terminates. So what is the breadth first search? Takes the exponential time. How it takes the exponential time? Because firstly, the first child will be expanded completely. If n is the maximum depth of the node in the search space, In the worst case, the algorithm will take B time, and the space take is linear in the depth of the search tree. So the time taken by the algorithm is related to the maximum depth of the search tree. जितनी maximum जितनी depth होगी search tree की उतना ही time लगेगा. If the search tree has an infinite depth, the algorithm may not terminate, and this can happen if the search space is infinite. So it can also happen if the search space contains cycles or the multiple loops, and the later cases can be handled by checking for the cycles in the algorithm, and thus the DFS is not complete. So the disadvantage of a DFS, it is not complete when we are talking about the cycles. If the graph is having a cycle and if the search space is infinite.